Hey, hey guys. Good
Hi, good morning,
morning.
Professor.
Good morning. All right. Well, how many of us are here? Well, we'll give the others a chance to join. And in the meanwhile, if you have any bright ideas for coding today, think it up. I have one in case you guys don't. I was thinking something we coded before. I forget because we've done a couple of different things now, right? Uh,
Yeah,
Yeah, which is pretty cool. We actually did manage to complete a couple of working non-trivial programs in class, and which is absolutely fantastic, right? And it's not well, just so you guys know, it's not common. It's not common that students actually get this done. So you're a very unique bunch of students, really, because you're all participating and helping each other. And the only reason we're managing to complete all these things that we start is not because someone is telling you what to do, right? Because every professor has tried this. I've tried this so many times, right? You keep telling people what the right thing to do is. It never works, right? Because there's one vision and there's 5,000 people, but there's 5,000 different visions that this one person doesn't see, right? So the reason we've been getting all these things through the door really is because even if I wasn't there, if I just gave you an idea of, hey, this is really cool, let's try and do this, and provided you have the basic knowledge, right, of what to use where, which really you don't need me for, because technically, if you think about it, if you sit down and think about it, the only thing I gave you there was speeding it up. A Google search for something that you didn't know will probably take you 20 minutes, right? And all I did really was stand here and as you guys are typing and just telling you, that's what you should use here and this is what you should use here, and basically cutting your search time, from the 20 minutes to the 2 seconds, and which eventually you can. So the reason these things have been pushed out through the door is really because you guys are all working together, right? And because everybody has a common vision, you're all going in that direction. And so I'm very lucky to have a bunch of students like that, which means I'm actually being encouraged to, I got to do this continue thing in case Peter comes by. Yeah, I don't know what I was saying, but yeah, I had a couple of ideas we can try and implement today, which really is cool. Yeah, which makes me more bold to try more things. And at any time, you guys can just tell me to, focus more on what we've covered so far, or certain concepts that you want to talk about. I always, I tend to think most of the time practice is better than just, it's not better than at most times, right? Initially, reading about it is good. But if we get stuck there and reading and more reading, it just, asymptotes down very quickly. I think so initially reading has value to get to know the problem, scape, right? So you have what is being demanded of us. And then after you get to a fair idea of what you're trying to do, the better thing is not to, is to stop reading at that point. I think the same thing with Quest 2, right? So especially since you guys are now coming up to the end of 2A and then thinking about 2B and all, I think this will help greatly. Is you should look at all of your homework, right? And now, whether here or in a grad school, everywhere, homework should basically consist of 3 phases, I think, to be most productive. Optimally, I think this is one of the optimal divisions, right? There's maybe multiple optimal divisions, but I think the initial phase should consist of just reading, right? No doing, just reading, so that you can understand the problem. Which is, and I think that get a news pack in your hand, and then it's like a couple of days of just reading. Okay, you one mind the cookie on an cookie on an yeah, just reading for a couple of days. Don't code. I think that is the danger that most programmers get caught in, is they start coding too early, right? And when you start coding too early, then here, Well, yeah, so most programmers start coding too early, and I think that is the downfall, really, because you get stuck. You get stuck because, not because they're less productive, right? The thing is, you can be equally productive, but productive in the wrong things, right? Because I think I've told you before. I've known so many brilliant, absolutely brilliant people, right? Absolutely brilliant people who didn't go anywhere. But I know they're brilliant, right? And then they're still not going anywhere. And this is life lessons to be learned. But the reason I can see the reason they're not going anywhere, even though they're brilliant, is because where I was going with that is because all of their energy, all of their brilliance is being spent on the wrong things. And the reason it's being spent on the wrong thing is because they haven't learned what is important, right? And so brilliant people trying to solve a problem, right, may not find a solution. Why? It's because they haven't understood the problem. They're still firing on the same number of cylinders. They still have as much horsepower as everybody else, but they're not firing in the same direction, right? They're going somewhere else, right? And depending on whether it's one goal or multiple diffuse goals of low value, I don't know, maybe they'll find it, right? Because it says, what goes in has the law of conservation of energy, something like that, right? Pseudoscientifically. But if they just channeled all of that into exactly what they want, they wouldn't have wasted a lot of, and I think that is how you crack hard problems in programming, right? So it's funny that I was triggered to talk about this because 2 days ago in the CS2A subreddit, someone was really literally banging their heads on the wall, right? And another student piped in and said, everything I see that you've done right, right? So unfortunately, you've done it right. Unfortunately, what you've said here is right, which means that the problem is somewhere you don't see, right? This is the easiest problems to find are the problems we see, right? The hardest problems to fix are the problems we don't see. And so he said, unfortunately, you're right. What you've cited is right. So the only thing you can do now is take a break, right? And the reason a break helps is because it puts some distance between you and the problem so that the problem doesn't loom so large in your mind. When it looms large in your mind, you can't find the solution, right? So put some distance and then it'll settle down because, close by, there's a lot of energy and all your electrons are, Brownian motion, whipping around, bam, 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 like that, okay? So far away from the problem, you can cool down your electrons, right? So that you can look at what, what the thing requires. And so, you may end up coding an equally profound thing as a quest requires, right? But unfortunately, it doesn't pass a quest because, it is brilliant, but it doesn't get you the trophies, right? So we want the trophies. So it's better to find out what the quest requires. And the reason I'm saying that is because starting from now, the quest requirements will start getting more and more, I don't know. Actually, it's not even in 2A. Maybe it's to 2B and 2C. It starts getting more and more cryptic, right? So you got to put some effort into deciphering what I say as much as what I say. I guess I don't know. It's up to you. Well, that's if you choose to continue on into my 2B, right? If I didn't. All right, good. So here, there's a couple of ideas that came to me, and if you guys are not. When what time is it now, by the way? 12. We got 3 minutes to actually start coding or talking about useful stuff. Any of you guys should just feel free to butt into the conversation and take the airwaves. Okay, anytime. That's perfectly fine. I think.
I just want to mention I'm gonna leave a little early because I have a phone interview.
Oh yeah, sure. No worries. No worries, Mark. Yeah, best of luck with everything. Okay. Yeah. You can take off a little early too if you want, if you just want to, settle down and prepare your mind, right? Because here you'll be all energetic in this class, and then when you go to the interview, you're not thinking. Yeah. You can take off early if you want. Well, it's all going to be on video, right? It's all going to be on video. You can catch up later.
That's true. Thank you.
Yeah. All right. Okay. Cool. All right. Take it easy. So the idea I had in my mind was, I don't know, we coded a couple of games. Oh wow, this is where it all started, right? We coded a couple of different games, and I think in the first game that we coded, there was some sentence we wanted to display to the user, but we wanted to display it with a drum roll or something, right? Not like that, bam, right? So some kind of effects, and unfortunately, we're not doing this in a even a semi-modern programming language, right? We're doing it. Everything we're doing is really console applications, right? The stuff that can be run on the server in the back end in C++. And so that means we don't have, as we sacrifice a great deal of power to interact with the user into other libraries, right? Other libraries that can do the GUI part of it, right? So there's pictures and all these things. So, and also stuff like event-driven programming, where you have to wait for the user to do something and so on. There's some primitive ideas built into C and C++, console IO, but drawing pixels or things, it's harder in using C without using graphics drivers and special graphics libraries. But it's all very simple using the right libraries. But I'm saying just in raw C, and raw C, it's hard, or C++. But what was I going with that? Yeah. Okay, so how do we do it in a console? So I was thinking, how can we, because most of the time these programs we're running, one of you, right, Chanyi or someone, goes to online GDB. Who was it? I think Jing Han was the one who introduced online GDB. Yeah. All right, so go to online GDB and you get a console, and then you run it. How can you have any special effects show up in that console, right? It's a strictly ASCII console through your browser, even, right? Not even through your machine directly. So how do you do some effects? And I thought that let's do it the really primitive way. This is the way I did it when I was a student, right? You see, imagine how long ago this was, right? When I was a student like you, and C++ didn't exist, only C existed, right? So I think I wrote it in C. And I want to try and do it. So if anybody's game, it's like 5 lines, right? 5 or 6 lines. And we'll do that. And then we will still have sufficient time to switch programmers, right? Or switch drivers. Someone else can take the screen after that. And that person will actually do a game. This game, I want to make a start on it, okay? It'll take a couple of lectures to finish, but I want to make a start on it because this is something that we tried to do last quarter, right? Did a job, and the quarter before we did a really half-assed job, right? And then I said, okay, next. So this time I'd like to do something, because especially since we've already done these other two, it's really cool, right? And obviously my offer still stands. If any of you is interested over summer, having completed up to 2B, right? And no, not to at least the middle of 2B over summer or something like that, right? So before you start middle of Quest 6 or something, if you're interested, I can zoom you through, a couple of freebie one-on-one lectures over summer to develop a web application, right? So just an HTML page with JavaScript. Essentially, you won't even be writing a lot of JavaScript. You'll be taking the C++ code you already know and then making some tweaks there, and it'll become JavaScript. Bam, like that, okay? And then you can embed it in a web page and browser and things like that. And you don't even need a server, right? Because it's all JavaScript. You just host the static files, and it's a web app. I can show you how to do that. And and later in summer also, if anybody's interested in doing that Volcano Island game in Unreal, right? Using C++ and blueprints. Potentially a VR game, right? Hopefully you should have completed 2B, right? Complete 2B before you get to that. But if you complete it really quickly on your own, that's fantastic, right? So I will walk you through that too. We'll have a few Zoom sessions, not 2. It'll take a while, unless you're already familiar with, the Unreal universe. I think they have a bunch of really good tutorials. Their education, I don't know what it's called, some Unreal Edu or something like that. Right, so their portal is very good. You can do all their courses if you want. I can zoom you through some of these things, and it'll be fun, right? It'll be fun to have this project done, because then I can put my Oculus on and then play this game that you guys have done, right? Enter your world. I can enter your world. and navigate to find the right pods for the right, things to spew out of the volcano, right? Harry Potter quotes and Star Wars quotes. And who knows, you may even develop the game more to make it even more interesting than just finding random sentences. Okay, all right. So let's say two of you have made up your mind to go today. And I think the first one should basically take the screen, right? Take the screen. And before you take the screen, make sure that we'll be using the browser. We'll be using the browser, and make sure you don't have any personal information on the screen, okay? Because sometimes I remember. So last class, I remember David had some personal information, and then before I could hit publish, I got to email him and say, tell me where these places are. So because otherwise I have to look at every single. And I've already been through the lecture once, right? I understand how boring it must be for you guys, right, to watch the videos. But I don't want to leave these public things. You got to tell me before you take the screen. Make sure you don't have any private information showing. We need to use a browser, hopefully a private tab, and then we need VS Code or some, even Notepad will do. This is like 5 lines, a 5-line program. Oh, we'll use cpp.sh, Replete. Any of those environments is fine. Actually, we should try it using, online GDB or Replete, because that's if the effect works there, it'll work anywhere. That's like a very primitive kind of terminal. Although we can try and see if the terminal understands ANSI codes, right? In fact, you can Google. This is really, really ancient, going back to the primitive days of the universe, when just after the Big Bang. And actually, it was long after the Big Bang, right? When in order to control the position and color of the cursor on a text screen, right? Characters, right? ASCII screen. Thank you, Turkey, right? So we used to send control codes to the cout, right? Control codes to the screen, right? And control codes always started with something like an escape character and funny things which weren't sent to the screen. So the screen would basically wait until if it got a control code, it'll wait to see the first few characters and then understand what the control code was. So in other words, you actually had a little mini software CPU built into the screen itself, because the screen would react to the control characters. And if the screen can react to the control characters, your control characters are basically the bits you're going to use to program your screen. So using your ANSI code, you can essentially program the screen to do a computation. And so it is so funny. Back in my student days, we had some fun doing, crazy ass things like that. Anyway, so and there's a library called Curses. We won't use that. In fact, the Curses lets you do position things on the screen, but we want to do things in an even more primitive way. And for 20 years, I think I've had this doubt to maybe, I don't know, right? I think, is this going to work? Is this going to work? And today we'll find out. Okay. All right. Thank you, Turkey. All right. So let's say let's create a class. All right. Let's do it the proper way. Let's create a class. Class called display, right? Display with effect. Well, can someone think of a nice one word for display with effect? I'll just call it display with effect for now, right? The name of the class is display with effect. Yeah, I think that's nice. Thank you. With effect. Okay. All right. Now in the class body, we're just going to have a whole bunch of static public methods. Okay. So what we'll do is, we don't even have any private and public. We're going to say static void. And then let's do the first effect. What should we call the first effect? Let me see. Roll underscore chars into place. All underscore separated. Roll chars into place. Roll chars into place. Okay. So here's what I'm thinking, and I hope this works. We're going to use the /r. So the funny thing about the console, right, which you can exploit, that now that you know this, you can exploit this, right? In the console, when you send to cout, you see that /n or new line, endl, you put at the end. Yeah. Now what that means is two things. We think there's only one thing. It actually means 2 characters, right? It means multiple things, but it's 2 characters. It is actually sending 2 characters to the screen. First character says, okay, go back to the beginning of the same line. And the second character says, go to the next line in the same column. Okay. So in fact, your /n on Unix or endl means two things. It means a carriage return and a line feed, okay? That's why in ASCII, you have two characters for going to the next line. It is CRLF, carriage return, line feed, okay? And carriage return, I think, is ASCII 13, and a line feed is ASCII 10, okay? So there's two characters. Now, the funny thing is, I think that these primitive terminals are unable to do, well, what we're going to try and do is leverage carriage return, right? Leverage carriage return and overwrite the same character over and over again. So we're not going to go to the next line, right? We're going to print a line and then go back to the beginning of the line and print the same line over again with some characters changed, so that we have a bunch of characters as a truth, and that is eventually going to roll into place, okay? So I think this is how we'll do it, okay? We're going to do a bunch of loops, and then we can talk about this program, right? I think that'll be interesting. So anything that you don't understand, we can talk about, and then I think there'll be a bunch of concepts here that will be interesting. Okay, now let's do the body of that program, right? In that file, in fact, call this file, instead of test.cpp, call it, yeah, call it, what is it called? The name of the class, DisplayWithEffect, yeah, .h, DisplayWithEffect.h. Right now, anyone who knows, anyone who looks at this file knows, okay, it is a file, it's a header file that has one class in it, and the class of the name of the class is DisplayWithEffect. Okay, so all right, great. Now we're going to implement this. And then what we'll do is, after the implementation, we'll also cut the implementation from here and put it in the DisplayWithEffect.cpp, right? So in fact, we'll structure this so that we have a proper project with a header file and a CPP file. It's something we're going to do very soon in quest number 6, okay? So this is a dry run of that in a slightly different scenario in class. So I think this is really cool. So those of you who are, is everybody following along? Hey, hang on one sec, okay, Turkey, I want to make sure how many of you are here and who's not here and so on. Just give me one second. I'm going to shrink the.
I'm here.
Hey, yeah, I know. Okay. So, all right. Some of the regulars are not here. Okay, and David, Jacqueline, who else? You're a Chanyi, do I see Chanyi? Oh, Chanyi, okay, all right. Oh, yeah. Sometimes you have a cat picture and sometimes you, are you the one with the cat picture? On Zoom? Yeah, okay, so sometimes you have that. And sorry. All right, cool. Great. Excellent, thank you. All right, so here we're going to do this implementation, okay? So let's do a comment at the very top to say what we intend to do, and then go ahead and implement that. Okay, what we intend to do is, so by the way, DisplayWithEffect is going to take a string, okay, string s, and in fact, you can make it const reference to a string, right? Const reference to a string, because we're not going to change the string. We're just going to display that string, right? So it takes a parameter. No, you had to, it takes a parameter. It takes a parameter, which is a const reference string. Const reference to a string, right? So you can say const space ampersand for a reference, and then str. No, const string, const string space, and then ampersand s. Yeah, str. That's fine. I think it's s or str, right? I gotta keep because now I've got the screen only half the thing, right? Half of my screen is taken up by your console or your window. Actually, let me increase the font size. Okay, I don't want to be putting so much effort into peering. Okay, yeah, thank you, Turkey. That's much better. Thank you so much for that. Okay, all right. So roll chars. You want to call it chars with a Z? Okay, that's fine. That's really cool. Okay. So I was thinking chars with an S. All right. So the comment should say use the carriage return character to overwrite the same line over and over, overwrite the same line repeatedly, gradually rolling the target character into place, okay? And then the logic of the code will make it very, very clear how we do it, okay? Because if now we're going to do the code, and if someone, now you have to put yourself in the shoes of a random person, okay? Not you, because you know about this and you know the context. You have to put yourself in the shoes of a random person and then look at this code and say, okay, well, I've read the comment and I've read the code. Do I understand what the code is doing? Is it doing the right thing, okay? Now you got to think about this from the perspective of a person out there, okay? That's really hard and it takes some time getting used to that, but you have to do that. And then you can tell me, and then we can go around and play with this and make sure that if you come back to this like 50 years later, right? Where you don't remember anything and you look at this and you still understand what it does. Okay, so that's really what where we're going. Okay, so here's what we're going to do. Now, the first thing we want to do is get the length of the string, because we want to know how many characters there are. All right, so let's say size t len equals s dot length. Okay, so size t len equals. No, don't say ln, because ln is a function, right? It's a natural logarithm, and ln. Oh, anyway, in math. I don't know if the math library uses ln or just log. All right, cool. No, don't say ln. Len, len. I'm sorry. Len equals s dot length. S dot length. Yeah, okay. So we're going to get the length, and that's our len. Okay, now the other thing we want to do is we're going to create a vector of size t, right? So vector of size t, which is size t, and then say counts, right? Counts, and then the size of the vector, open parentheses, the size of the vector should be len, right? So in other words, and then it'll become clear. You can tell me if this makes sense, okay, later. So if I tell you, if I tell the display function, here's a 10-character string, print it out. The first thing it's going to do is allocate 10 random integers. Okay, so now what we're going to do is on the next line, after the vector. Oh, thank you. Thank you, Tricky. Right.
Also on line 14, if you don't make it length th.
Oh yeah. I said spelling.
Yeah.
Hey, Mark, you still here? Okay. All right. All right. Cool. Yeah. Enter one more time. Yeah, one more time. Now, put in a comment saying fill counts with random numbers. Okay, fill counts with random numbers or randoms or whatever it is, right? And in fact, you can have a line. You can have a blank line before that. Yeah. Okay. Cool. Now you're going to do a for loop and fill it with the output of rand for size t. Yeah, you say for size t, for size t, for size t, size underscore t. Yeah, I equals 0. I is less than counts dot len. I think counts dot size. I think it's counts dot size. I'm sorry, counts dot size. Now, here's a nuance, right? And maybe you will appreciate it now or later. Even though we know that I less than counts dot size is the same as I less than len. Okay, because len is counts dot size. Yes. Even though we know that, we are still using counts dot size, which to our eyes, it looks like it's a function call, not a variable. Okay, so a naive programmer might look at that and say, that's the inefficient thing to do, because you're calling a function where instead of calling the function, you could just use len, which has been pre-computed already one time. Yes or no? So we need all to be, we're doing a very simple program, but at the same time, we're talking about a concept which is actually very, very subtle and important at the same time. So I'm actually glad we're doing this really simple thing so that we can focus on the more important thing that we're talking about. So I want to know if we're all on the same page. What we're saying here is that a programmer could justifiably make that remark against Turkey, right? And say, why are you not using len? Because it's pre-computed and it exists in one place in memory, as opposed to counts.size, which looks like a function call. And so every time you compare I, it's going to do this function call and this weird dance and return a number, and that's what you're going to compare, right? So they could tell you this is an inefficient program. Don't change it, right? Inefficient program, you should be using len. Now, I want you to appreciate the other person's point of view before we say why we do it this way, okay? That's the reason. Many times in our classes, we're spending like 10 or 15 minutes talking about some totally tangential stuff, but really, I think these are useful because this will eventually, maybe not so much for your grade in CS2A, right? Because I don't think this is going to make any difference to your CS2A grade, right? But I think that this will really make a difference to your programming career later on when you're doing these things. And someone says, why are you doing this? This is not the right way to do it. Instantly, right? That they haven't thought through it. Because what happens is that This is defensive programming, right? What happens in the really, really remote chance that len, which is not declared a const, got changed? Okay, so, it's not, it's very unlikely, but it's possible, yes? However, no matter what the size of the vector is, counts.size is always going to return the right size. So you will never overstep it. So the danger of going out of bounds into the wildies and getting killed, right, is zero at this point, right? Maybe it was infinitesimally small before, right? Maybe it was like 0.0000001%, right? Because nobody's going to change len between that line and this line. Maybe this program will get big and len changes, I don't know, right? But still, so because there's a probability the program gets big and it changes. So there's some probability, right? Some epsilon, right? So that's epsilon, but even though low likelihood, and you're saying, no, I'm going to use this function call. So now that means that you're confident that counts.size is a constant time function, which the compiler knows to just replace, because if that value is stored inside of the vector object, which dot size is basically our getter, right? Dot size is the vector's getter. Actually, what they should have named it before the convention was, adopted, I guess, they should have said a vector, and all of the containers should support getters. Like, if they have a native, size thing, they should say get size rather than dot size, right? Because dot size, and in fact, this is a question I asked in one of the specs of CS2C, right? When should you use get and when should you use find in your method names? Right, because this is not even computer science if you think about it, right? But it's like crucially important, because to a fellow programmer who is looking at your code, when they see a get, right, they know it's just a simple get, it's constant time O of 1, so bam, like that, and the compiler it is the same as using a variable there, right? Even though it looks like a function call. However, if it is a dot find, you'll find very few programmers putting it there in a for loop, right? Like that, because find, who knows what the find, maybe it's an exponential find, right? Right, so find, so those are things that filter into your programming work, even though they're tangential and sideways, but they kind of reflect your decision, percolate into your decisions, kinds. So that's why we use counts.size, and that's why if someone says, why are you using counts.size, this is the argument you will tell them, right? They'll say, no, this is just defensive, and we're saying dot size because we know for sure it will never overstep, because the compiler has our back now, right? Previously, the compiler could not have our back. Every opportunity you get to make the compiler have your back for you, you should take, right? Yes, it makes total sense, doesn't it? Even in life, when people come to help you, yeah, we, wholeheartedly, not with, hidden motives, hey, what's the harm in taking it? So, so when the compiler says, I'll have you back. And so unless it's too much effort to do that, or you think it's something bad is going to happen because the compiler has you back for you, why would you turn it down? So I think that, every time the compiler gives you the opportunity to do that, you should do that. And this is one of those, right? It says, I'll have you back if you just tell me, right, how you want to iterate over. In fact, that's why I think some of the more recent languages, like Python, you don't even have to say specify these bounds, right? You just say, even JavaScript, even C++ now these days, right? You can say vector, if it's a vector, you can say vector.forEach or something like that, right? So they have these syntaxes, because technically, if you think about it, whatever you're doing right here, everything the compiler could do too, right? Because what we're doing is just automatic, right? We've already had the idea. We're just translating the idea into something more amenable to a machine, right? But even that is a mechanical process. That's really what we're doing. And so what we're doing, compiler can also do. And that is why in most of the more recent languages, you have better different syntax, right? And languages like functional languages, you can take, map these things into entire arrays and not know the size of the array at runtime. All these funky things can happen. But we'll do it the really, really primitive way. And again, I'm so sorry to waste all this. Sometimes you should just feel free to just say, let's go, just go ahead. We're happy, okay? All right. So fill in random numbers, okay? You say counts of I, counts square bracket I, counts square bracket I. Square bracket I equals the result return value of rand. Yeah. In fact, you don't even need the braces because it's just one line in the for loop. And at the end of the for loop, I hope everybody is convinced that counts will have a whole bunch of random numbers. Yeah. Okay. Now here's what we're going to do. On the next line, we're going to iterate over the length of the sentence. Oh, well, actually, you know what? Yeah, we got to make this defensive later. Okay, not now. We're going to, for now, we're going to assume that it's the same. All right, so for iterate over the length of the sentence, all right, for size t, I equals 0, I less than count, well, let's actually say counts.size. You know, let's just be defensive here. I less than counts.size. Yeah, no, I'm sorry. What you had was right. You know, you were typing ahead. Right, okay. I less than counts.0. Okay, no, what was it? Counts.size, I plus plus. Right now, we're going to print out one character at a time. Okay, so we're going to print out one character at a time. One character at a time, and decrement count at the same. So now we'll have a body, right, by braces and everything. Well, let's have no, we're not printing out counts of I, right? It's going to be double nested loop, right? One more braces. We're going to have a body. Here itself, yeah, that itself needs to be what is it indented in? Okay, cool. All right, now what we want to do is now, yeah, let's do that for for each character. Yeah, okay, all right. For I equal for j equals g. Maybe I haven't thought this through too, right? Let me think this through with you, and you guys can correct me. This is what I want to do. Okay, so we want to print all random characters. And decrement all the counts. Decrement all the counts. Print all random characters. Decrement all the counts. Except if the count has gotten to 0, then you put the target character in there, and don't touch it. But basically, if the count is 0, you put the target character there. If the count is not 0, you put a random character there. So that's what we want to do. Okay, good. All right, good. Let's do it this way. All right. So so for each character. I think the confusion resulted from the fact that we're using length and count interchangeably. Yeah, let's make it easier on a programmer. Just say len for now. All right, not counts. No. Just instead of count of I, just say for the length of the sentence. What we're going to do is no. Here, if I'm sorry. There's no nested for loop. I'm so sorry, Trudy. Right? I just thought through this. Okay. So yeah, if counts of I, is it counts of I? Counts, yeah, counts of I equals 0. If counts of I equals 0, oh, you want to do, okay. Yeah, let's do equals 0, double equals 0, because yeah, you could technically leverage the fact, but that 0 is false, but let's not do it. Okay, if it is 0, then we print the target character there, right? So enter. We can actually turn this into a ternary operator, I think, right? See out. What is it? The target character. What is the target character? S of I? No. The target character is S of I, right? S square bracket I. Square bracket I. That's easy. That's a real character, isn't it? That's what user actually wants us to print, right? So if the count is not 0, we don't print the target character. We actually print some random character, okay, and decrement count. So else should be the else of it should be within square within braces. Yeah, enter after that. Enter after that. Yeah, else. Yeah, and then open brace. Yeah, in fact, this else belongs to that if, right? So open brace. Yeah, okay. And what we want to do here is print a random character. So what we want to do is see out double less than, and let's typecast it to char, right? So within no, not sran, right? We're gonna create a random character using ran. Okay, so let's say what do you call what are we trying to do here? Yeah, we're going to do a typecast because we're going to generate a number. Right? We want to turn that into a character. So we want to typecast the open parentheses, open, yeah, and say char inside of that, char, right? What we're saying is now we're going to do the random magic and get a number, and then after that open another parentheses. In that we're going to compute our character. Not there. So char is fine. Just the word char is fine. Just the word char is fine. Tricky. Maybe that works because maybe that's a new syntax, but let's not go there. Okay, yeah, space there. No, just space, not semicolon. Now you want to say rand. No, open parentheses because that's going to be an expression, right? Open parentheses. So yeah, space. Space. I think VS Code is really getting in the way here. Do with this autocompletes. Okay, there should be some way to turn these things off. No, get rid of the inner parentheses. Get rid of the inner parentheses. Okay, outside of the yeah, great. Okay, that's what we want. Rand, call rand, open close. Now let's generate a random number between 1 and 26. A and Z, right? A and Z. 20. A and Z, so we can add it to yeah, the random number between 0 and 26. Yeah, plus 25. Yeah, okay, good. Yeah, 0 and 20. Okay, good. Rand percent 26 percent 26. So that's going to give us enough, but no, plus because you want to take that and add it to the ASCII value of lowercase a plus lowercase a within single quotes. Within single quotes, not parentheses. Now put some spaces around it so we can talk more. Yeah, put some spaces around all these operators, and then we can talk a little bit more for anyone who doesn't understand that line. Yeah, put some spaces around all the operators. No, not double quotes. All right, single quote. And then put some spaces around the plus and around the around the percent. Yeah, and then between the typecast and the expression also put a space there. After the char, open, yeah, there. Okay, so is everybody clear with what that line does? Because I want to make sure that we're all on the same page as far as that particular line is just one line. But what it's doing is that it's generating a random number between 0 and 26. Yes or no? Just start from the innermost parentheses because that's how the CPU is going to do it, right? Innermost parentheses is going to generate a random number between 0 and 26. Now it's going to take the ASCII value of the letter A. I don't know, maybe it's 122 or something like that, right? And it's going to add that random number to that. So it's going to turn that A into some letter between the ASCII value of A and the ASCII value of A plus 25, which is the last one. A and Z. So it's going to turn this into a random letter. Okay, but still that's going to be an integer because the operation is done in integer space. We want to tell cout, don't output a number like 47 or 127. I want you to turn that into a character and print the character. Okay, so all of that is happening in that one line. And that is the reason why we spent a little bit of time on that line. And this is what you're going to be doing, right? Most of the time. Because if you have programs that are so big, it's, you think, oh, well, I'll get to it after coffee, right? But if it's just one line, you think, okay, well, I can read it while I'm drinking coffee. All right. So our goal is to make things as small as possible, but no smaller than that. Okay. All right. Good. Everybody okay so far?
So we're basically casting that into a char?
Yes, typecasting. All right. Okay. And so the next line is we also want to decrement the count, right? So we want to say counts of I minus, right? On the next line after the cout, counts of I. Counts of I. Now, is everybody okay with the overall loop here, right? Now, so far we haven't output the thing yet, right? So it hasn't been flushed out to cout, right? So in fact, and we're going to simplify this, make this after the for loop, get out of the for loop. When do we exit the for loop? Oh, so we need to know when all of the characters have settled. How do we know if all of the characters have settled? All right, so one thing we can do is we'll do it the bad way here. The better way was actually going to be better. All right, the bad way is that after generating that sentence, we're going to compare it with the target. If it is equal to the target, we're done. Yes? Okay, that is a less efficient way to do it. The more efficient way is to actually find out when the last character has been fallen into place. Okay, so here's what we're going to do. So after having in the for loop, after having done that, it should be in the for loop. I'm sorry, it's inside the for loop. Yeah. Now we're going to print the sentence out. Okay, we're going to print the sentence out. Yeah, cout. So we actually printed it out. What we want to do is print the /R character out. We've printed out all the characters, right? Now we're going to print /R, saying all the letters have been put in place, right? Some of them are random, some of them are real. Now the cursor is here. Now /R, take it all the way back to the first one. Okay, so /R. Okay, now, but /R, unfortunately, right? /R, unfortunately, the way the system has been designed so beautifully is that will not flush it to the user. Okay, when you send anything to cout, it's just going to sit in some memory buffer. Okay, it will not make it to the screen. All right, you need to flush cout in order to say, okay, I'm done with it. Now I'm not going to send you anymore. Now you're ready to send the ship off to Mars. Okay. So, because sending the ship to Mars is really expensive. You don't want to send it there until you give it the okay. Really, you want to send like 15 items, right? So you send all of the items, and then you have to send the signal. One other way to do it is to send the special item, which always says, okay, that's got to be the last item. I don't have any more. That special item is /n or endl. Okay, when you send /n or endl, you don't have to flush it explicitly because the system knows to flush it for you because it's built into the system. Because that's what happens 99% of the time. If you send it anything else and you still want to flush it, you need to tell it how to flush it. Okay, so we're going to say cout.flush on the next line, right? And on the next line, you're going to say on the next line cout. I hope flush exists, right? No, I think it's dot flush. I think it's a method called dot flush. Yeah, okay. All right, I think it's open close parentheses. All right, now after flushing, we're going to compare. Oh, you know what? We also have to build up the string. We have to build up the string. Yeah, let's build up the string, not just send it to cout, okay? Because we need to build up the string and then compare it to the other string. So let's at the very top, after the vector declaration, and just also say string copy equals s. Copy equals s. Copy equals. No, so space. Yeah, equals. No, equal. The equals. We're creating a copy that is the same as the input string. All right, now enter. Okay, now here instead of cout, let's just say copy of I equals s of I. Copy of I equals s of I. Copy of I equals s of I. S square I. Right. The next one is going to say copy of I equals instead of cout. Just instead of cout. No, just instead of the cout. No, not the whole thing. Just yeah. Copy of I equals, and then all right, and then the space on the other side of the equals. Is everybody okay with that? And then now here, what we're going to do is basically cout double less than copy, because no, on line 35, on line 35, where you actually have the cout before the /r, you also want to send it to copy, because the copy is what you've built. Yeah, you want to send it to copy, and then the /r. Now, however, after flushing, we want to check, is the copy the same as a target? If the copy is the same as a target, you can break out of the loop, right? Now we can say if copy equals target, if copy equals target. What is a target? No, it's s. Sorry, I'm sorry. Copy equals s, break. Now, strictly speaking, right, a purist can say this is not an algorithm because there is no definite condition for the algorithm, this function, to ever terminate. It is possible. It is possible that the algorithm never terminates because, no, it has to terminate, right? Because no matter what the count is, it has to hit 0 at some point. Yeah. Okay. So yeah, this is a proper algorithm. Okay, great. I think that's it, right? So this is our first method for a display. You can obviously write many more, right? Now let's try it out. I'm actually eager to see if it works. Let's say, let's create a sentence here in main. Say string. No, we need a sentence, right? Yeah, display with effect. You just call it. Yeah, display with effect. Dot. No, you got to say dot, right? Oh no, it's double colon because it's a static method, right? This is how you call static methods, by the way. Okay, there's only one copy. It's not attached to each object, so you don't need an object to call a static method. Is this a static method? Did we declare it as a static method? Go up to the declaration. Static void string. Okay, yeah, good. Because it's static, right? Because it is what a static method means. Have we talked about static methods before? Right. So we talked about methods in general, right? A method is basically a function that's attached to an object. Yes or no? I mean, I need everybody to be on the same page here. now I'm going to reduce the size of the screen, okay, so I can see more of you. Okay. Oh, good. Jacqueline is here. Who else? Oh, Isaiah is here too. Isaiah, are you here? Isaiah, are you here? See, he didn't respond now. Okay, and David is not here either. Okay, good. You guys let them know to watch the video. What was I saying before? I'm sorry. Yeah, okay. So a method is basically a function that's attached to an object. Is a method. Yeah. No, however, sometimes I want a function, but I don't want it to be a free floating function that anybody could access. I want it to be associated with a class, but I don't want a brand new copy of the function for every object I create, right? Every object should not have its own copy. I want one copy that's attached to the class itself, to the blueprint of the class, to the class definition, right? One copy that is shared by all of the objects rather than one copy per object is what kind. So we want a variable or a function that has that property, right? A property. So this is a third kind of property, right? So we've talked about private properties, public properties, and so on, right? So this is a third kind. It's a very important kind. And I think I'm so glad we brought this up today because, we actually do have to have an entire, I think, right, entire lecture devoted to this because this is a very important property because this is another kind of abstraction we want. We want an abstraction in which nothing is visible to the world, right? We want an abstraction in which everything, is basically free floating, not attached to anything, right? Something that's attached to a particular object and you can have many copies of it, and something that is attached in the class to the blueprint, not to objects. So there's only one copy. So if there's one variable like a population, right? Population, there's one variable. It doesn't make sense to have multiple copies of the population variable and 15 different, or 15 trillion different entities you create, right? Because there should be one variable that says that is a total count of all the objects you have, right? So that means that there's only one copy of the variable. Although it makes, because having many of those is a headache. You don't want to, and you maintaining updating is not possible, right? So you only have one, and all of them refer to the same thing. If any of them updated, it updates for everyone. Now we have to appreciate that it's really hard to get that right without static. How do you do that? So you have to build in all. So in order to make that so easy for us, the compiler provided this one simple keyword called static. Right? So we just spent so much time talking about it, but the compiler says just put the word static in front of it. I'll make sure there's only one of it. Right? It's one of it and it's attached to the class itself. And you can have any number of objects, and anytime the object tries to get it, I'll get the one copy that I have, right? Whether it's a variable or a function, there's only one. Okay. Now, if you don't need an object, so suppose, let's say you have a function, right? Suppose you have a function that is static, not a method, right? So anything that's attached to an object, you have to say the object dot something, right? But if it's a function that's attached to an object, you want to call the function. The classic example is not in C, but in C++ because of the math history. But I think in Java and languages like JavaScript, right? So if you want to use a function like sine or tan or log, right, from a math library, you say math dot, yes? But you're not creating a math object saying my math, my math, and then my math dot. You're not creating an object and calling the method on the object. You're calling the method like tan or sine on the class itself. Yeah, that is called a static method because it's not just a free ass function that is floating out there that anyone can call. It has to be a function that is part of a family of functions that we call a math function. They're all grouped together, structured.
So Professor, I had a question.
Yeah, sorry, Chris.
So static methods of a class don't need an object to be called?
No, objects are never called. Objects are just created and destroyed, right? So I think we had, not just you, right? Many people in CS2A, maybe even I think 2B and C that just came in directly from somewhere else. They also made the same mistake saying, oh, you don't call this variable here, or you don't call this object there. That's very loose terminology that we shouldn't, we should be very careful not to get lost in, right? Because you never call an object, right? You basically call functions and methods. In fact, I think in Objective-C and SWIFT, you only pass messages and, really we should just be thinking of objects as variables, as like integers, objects, right? So if you have a method, it needs an object to be called, right? But if you have a static method, you don't need an object. But how do you call it?
That was my question. If you have a static method, you don't need an object to call that.
You don't need an object. Right? Yeah.
Okay.
But how do you call it, right? How do you call a static method that belongs to a class?
What do you use? Wouldn't you use the class name and then
Yes,
the double
thank you, Chris. Yeah, that's exactly what we'll do, right? So in order to tell the compiler that it's not just some free floating function, but I want the function that is attached to this class, we're going to say display with effect, double colon, right? I can actually just barely make out the letters right now, but I can, right? Don't bother increasing the font, okay? Because, yeah, okay, all right. Yeah, and what is it called? Display with effect. Yeah. Oh, thank you, Turkey. Thank you. Display with effect. I think that's the name of the function. Yeah. Oh, roll chars into place. Roll chars into place. Right. And let's give it some sentence. Right. Let's give it a sentence to print to screen. No, I'm good. You just give us a random sentence. Can someone run a random sentence from last class and give us a random sentence? Right. I'm gonna type something in, right? Oh yeah, let's just say CS2A is such a cool course to do. Yeah, this is a random sentence generated by the incredibly brilliant folks at CS2A. Okay. Generated by a human. I thought you were going to type lunatic, right? Because I can't see so clearly from here at this font size, but human, I think is what you typed. Okay. I think you need a new line. Oh, you don't? Do you need a new line? No, you don't. No, you shouldn't type. You shouldn't give a new line. Okay. In fact, we can make the function better by also not now, right? You take it in your own time. We can actually make the function better by as soon as you get the string, just pre-process the string to get rid of all the non-printable characters like new lines and so on. Because if you have new lines, this whole thing is screwed. It won't work, right? You got to get rid of all of that, or at least replace them with spaces. All right, good. And we should be able to run this now. And let's look at the output. What's going on? Let's see. I'm going to increase the font size. Okay. Cannot declare. Yeah. Okay. No, I could read it before. Z++. Where is here? Cannot declare member function static void. Oh yeah. Static. I don't think the keyword static occurs in both places. I think in only once. No, not here. Not there. I don't think you have it there. I think so. All right. There's some weirdness here. Try it now. Did it compile? Did it compile? Did it print some random junk? Maybe there's a bug. No, it didn't print anything. Oh, that's what it printed? Okay, is that the same length as what we asked it to print anyway, right? Because it kind of looks really funny. What did is this is not even the same length. So something weird is going on. We can debug it. We can debug it here. And it's kind of cool that it's not working, right? Because then we get an opportunity to debug it and see what's wrong. Is that okay with you guys? Yeah. So I don't know. Nobody's speaking up. Is this okay? We're going to try and debug it to see what the hell is going on. Why is it not working?
Yeah.
Hey, Isaiah, is that you? I think I just heard you. Is that your voice?
No, it's my voice.
Oh,
It's Hoyanli.
yeah. Harry, yeah. Well, I'm still equally delighted, of course. But but I thought I heard him when I didn't hear him before. That's why I was that. All right. Let's debug it. Let's set a breakpoint in the function, in the static function. Let's enter it and see what's going on. Yeah. In fact, what we should do is change the /r into a /n for now, and it's just going to print out one on each line, right? It's going to print out one on each line. Now we can actually see that's what's going to come out, and we'll know, right? Yeah. Okay. Let's go to the very top. Why is it not even changing? All right. So it's just changing things and not. I see. Our logic was screwed up, right? So we just need to fix our logic. So what we need to do is basically before we even, we shouldn't be going the other. Something is funny. But after we've taken a copy, let's just remove all of the characters in there and just say print random, fill them with random characters. How do you fill the entire thing with random characters? Let's just loop over the SFI really quickly and set them all to spaces, right? If you don't mind. After you get no, on the first line, on line 24, that's the first thing we want to do, right? Enter. Oh, in fact, you can do it on the same line, right? In the for loop, make in the for loop on line 23, line 23 for loop, right? You can make that two statements, so it'll have a body now, braces also, right? Yeah, okay. And then you can also say copy of I equals space, right? We're just going to zap all those characters. Obviously, we could have just used an empty string, but I wanted to make sure that it was at least this big. So that's the reason. Copy of I equals space. Space in quote, space, quote. No, I think it has to be double. Yeah. Semicolon there, and then close that. Semicolon at the end, and then close that. Now, yeah. Why is your good. Thank you. All right. So now we have the very first string should be all spaces, and then next one we should have these things gradually roll into place. Okay, run it now. I just want to see what it looks like. And also, I think it happened really fast. So that's something we need to. All right. Okay. So something is weird here. Okay. What is the first thing that it printed? Is printed all spaces, which is good. And then it turned the first P first into a P. What is our target sentence? What did we ask it to print? This is all right. So the first letter should actually be a T, right? Uppercase T. Why did it not print an uppercase T is a question we're asking. So let's go back into the function. All right. And so we have a whole bunch of random numbers, I hope. Yes, we have a whole bunch of random numbers, and that many. And all we're going to do is we've got a copy, and if count step size. All right. So, and then on line 29, is everybody following along? Right? Yeah. Are you all reading the code? Just right. Maybe ahead of me is fine too. That's okay. So, all right. So
I feel like line 25 just clobbers the.
Yeah, we want to clobber the copy. We want to clobber the copy and then build the copy up slowly one by one. We want to clobber the copy. Yeah, and then build up the copy slowly. So for I constant size.
I think we need a third one as a buffer because the copy going to be cleared before it even carries the value of S, because the value of S is not in the second for loop.
Well, I mean, you still have S, right?
We have S. S carries the actual value.
Oh, here you go.
So you don't need a buffer
S
if
actually
you have S.
carries a con. So so count of I equals 0. If it's 0, let's be defensive and say it's size T, right? The count is counts as size T. I think it's a size T vector. That's fine. Equals 0. Then copy of I equals S of I. That's fine. Yeah. Then the actual character. If it's hit 0, then it has to be the actual character. And otherwise, you're going to say it is a random character. So why is this not even? Why is it not working? It seems to me like it's a perfectly fine piece of code right there. So I hope someone can find the bug there. Okay.
You just try instead of equals 0, not equals 0 on line 30 and see what happens.
Okay.
Just run it, see what happens. Huh.
All right. So that's great. So I think what's going here, I think this is what is going on. Char of I is probably overriding the previous character, maybe. Just set it to X, right? Instead of random character, just set it to X. Just comment out that line and set copy of X I to X. Oh yeah, right. Yeah, and then set it to X. Thank you. Yeah, uppercase or something like that. Some known character within single quotes. It has to be within single quotes, and then semicolon after that. Yeah. All right. Now run it. Now I think. What's going on? Why is it not even entering that loop? Why is it not? Is it not even getting in there?
Well, I guess it
Yeah, of course.
makes
It's never
sense
0, so it's never getting in there. It's never 0, so it's never getting in there. So it's never incrementing.
So we can change 30
That's
now.
pretty dangerous, right? Because an account will never get 0, and no, it'll have to do it. No. I think you have to put in the double equals there, not equals, right? And double equals 0, can copy of I equals X. Yeah, run it now. All right, good. It should, at least at the end, it should be the same length as the other one. Is it the same length? Okay, so it is the same length. Now, what happens is that instead of X, if you send it to that, set it to that random character, it's freaking out. Yes. So let's try and do this here. Above that line, yeah, create char C equals. Yeah, above the copy of I equals, right, on line 30, enter, yeah, on line 33. Hit enter on line 33. enter. Now say char C equals, and then have that char rand %26 plus A, all of that, yeah, put it there. And then let's assign C to this, right? Yeah, maybe that, I think, I have a feeling what happened was that even though we typecast it to char, it was using an entire integer, and that integer was taking that byte and also overriding the previous byte, right? I can't think of any other reason right now, but let's run it now and see if this works. It's still not working? So that my theory was wrong. Okay.
I think the issue is counts.
Counts is the issue. Where's the issue in counts?
Because it's never equal to 0, so you'll never get the.
No, you are. It
true
has to
number.
get equal to 0 because you're decrementing counts of I.
Huh.
Right? So every time you print something out, you're decrementing counts of I. And in fact, the reason it's hitting 0 is why we're coming out of the loop, because otherwise we'll be stuck in the loop forever. No. Yeah. I think that's right. Otherwise we'll be stuck in the loop because copy will never equals S. Copy will never be equal to S, and it'll be stuck in the loop. Yeah, how are we even breaking out of the loop? Right? Why are we breaking out of the loop if it never equals S? It's not equal to our target string, and yet we're breaking out of the loop. So what's going on there? So we have something really easy to debug here. Okay, so I think it's a really juicy opportunity, right? So why are we even breaking out of the loop when our target is not equal to the So all right, so let's see. Do you have equals instead of double equals somewhere? Hang on. No, further down. Copy equals S. Break. Okay, so at some point, copy is equal to S, and we're breaking. We have to set a breakpoint and then debug it, and we'll find out exactly what's going on. Right? This is a great opportunity to use a debugger. Is everybody okay with this? I set a breakpoint. Set a breakpoint on line 22. It's a breakpoint on line 22. The way you do it is right-click in the left margin. Right-click in the left margin on line 22. There. Yeah, I think that's what it is. The red circle. When I see the red circle, it's probably a breakpoint. Okay, if you run it now, I think it'll just stop there, right? And wait for us to continue. It didn't stop? Oh, you have to say something like run and debug? There's some flag there. No, there. If you just mouse over there, it says run and debug. If you mouse over the red button. No. I think you have a drop down. You have a drop down on line 22. Yeah, there. I'm pretty sure I saw run and debug appear. Not there.
What's to the left of the red
Start
dot?
debug.
Button?
Start debug.
Yeah, that will work.
Build finish with errors. So something didn't work. So there's an error here. Let's fix it. Cancel it. Cancel. What is the error? Why? What is our error?
I don't think
Oh,
my
you're not a semicolon?
debugger works. I don't think my debugger works well with Jesus.
Yeah, the debugger is not working in the VS Code.
Yeah, it's not the program. It's just the
Oh, I
debugger
see. Your
itself.
debugger is not set up yet in debug code. All right, let's debug it this the old-fashioned way. Right? Just let's not use the debugger. Get rid of the breakpoint, and then get rid of the breakpoint. No, the breakpoint. Right-click on the arrow, the dot. Yeah. Okay. Good. All right. So the old-fashioned way of debugging it is we're just going to use print statements. Okay. We got counts. So as soon as you enter the for loop, just see out S and copy. Right. Not there. That we need our prep stuff to. That's our prep stuff. Right. That all is fine. All of that is fine. Get rid of the blank line. Yeah. All right. Now on line 29, hit enter. Line 29, hit enter. Right. And then say C out. Yeah. No, you want to do that? Okay. Endl. You want to do an endl after that. So you got to remember the first line. You want to tag it. You always tag your output. It'll be easier. Endl, and then tag it before that, saying S equals. Not there. No. Yeah, before after the S equals. You have the S. There, get rid of the breakpoint. Yeah, there you go. Right? You say within quotes, you say S equals. Right? So you know what you're looking at. Within quotes, open quotes. Yeah, there you go. Say S equals. And then because it's going to be in a loop, it's going to be iterating, right? So put in a blank line before that. So put in a /n before the S equals, right? Because then it'll come in pairs. Then you can see what they are. Okay. Now on the next line, you say same thing, except you say copy equals. Now you don't need the /n though, because you want the S and copy to be next to each other. Copy equals. and then copy endl, and then line up the equal signs so that the two sentences will be right under each other, so we can see what's going on. Yeah, is that does that look okay? All right. And then, put in a blank line after the two debug statements, and then tag what I tend to do, and you don't have to do that. What I tend to do is, this is something that we're introducing in the program we want to get rid of really quickly, right? And sometimes we forget. So I just tag them with 4 forward slashes on the very end, so that later on, if I ever need to make sure, no, it has to be back forward slashes. Yeah, 4, because, 2 means it'll just pick up any old comment. So I have a special comment, there's 4 forward slashes that I just stick places where I want to go and revisit. Yeah. Yeah, and you can obviously use 5, 6, whatever you want. Okay. Oh, you know what? VS Code is intelligent, and it basically deleted that, saying it's a useless comment. Even the comment is useless, right? It doesn't know that the comment is actually useful for us, right? So it just inferred that it's a useless comment. All right. If you run it now, we should see a whole bunch of output, and it should also tell us. Yeah, something is funny. So the very first, your very first copy. Yeah, right. Where does it start? At the very beginning. At the very beginning. Okay, copy equals some. Why? I see. Copy equals that. All right, and the next iteration further down. Okay, copy, and then it gets the first letter. It gets us. And why are equals not lined up? Is this not a proportional font or something? I don't know. Can you? Yeah.
Feeling it's because of line 25.
Instead of the spaces, just use hyphens, right? I think it's just this font is optimizing spaces into some really narrow space, right? Instead of the spaces in front of the S, use hyphens, right? Then no, in front, in before yeah, because that's where it's different from copy, right? So you just say, yeah, for the COPY, use dash 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 dash. Yeah, I think that's fine. And now you can, yeah, I think that looks good. Run it. Okay. Why now it's easier to debug, right? So why at the very beginning, no, you're moving too fast for me. Is at the very beginning? Why is the copy is all blank, which is good. And then the copy is getting filled with only P. Why is it getting filled with only P? So our logic is wrong, right? So that means that the way we're filling in copy is there's something funky with our logic, and that's what we need to look at. So our bug now is isolated to some small part of the code that we can focus on. Is that okay? Now we're actually doing the real thing here, right? Because we're just zooming in, and this is really good practice, I think, right? Is this good practice or not? Yes. Good. All right. Thanks. All right. So now let's look at the logic and see why is this happening? Why is this happening? This is exactly what you'll be doing in your quests, right? When things don't work, you're just going to be asking, why is this not working? So, and you're going to be sticking some output statements there. So go to the top where it's the first time it's misbehaving. In your console, in the console, get to the place where it's misbehaving the very first time. Is that where it's misbehaving? The first time, yeah, P. Yeah, there you go. PR. Why is it? Copy equals, yeah. The first time is where it's sticking the letter P. And why is it sticking the letter P in there? So, and now we can reduce the size of that. We need to keep that in view, and then we'll look at the logic at the same time. Yeah. All right, now let's look at the logic and see copy of I equals S of I. Now, it's being assigned S of I, but it is being assigned P. Why is it being, the copy of 0 is being assigned S of 0, but S of 0 should be T, not P. Yes or no?
Is it because counts of I is not equal to 0? It's going into the else statement?
Okay.
It never equals 0.
Going to the else statement. Mark is, I think, yes, I think Mark's answer is right. It's not even going to the first, the then part, it's going to the else part. And in the else part, it is generating a random character, and that character happens to be P. And it's assigning P to this. Okay, good. Thank you. So that so far it makes sense. Yes? All right, so let's go to the next, scroll down in the output window. So far it's making sense. The program is behaving as far as we can tell, right? So let's, yeah, so the next character is generated PR and so on and so forth. Okay, prep and so on and so forth. Okay, so it needs to go all the way up to the end. Okay. Now it's generated the first sentence. This is the time it's generated the very first. Now, why is it stopped right there? Why is it and exited right there? It needs to have the, yeah, I think that's what's going on. Oh, no, wait. Do you actually have?
It exited because it reached the counts.size, which at this point was the number of words. And this is the last one, which is the end.
I see. Okay, let's do one thing, Turkey. Get rid of the exclamation mark, because right now we're only handling ASCII characters, right? There's a plus 26, and who knows what exclamation mark plus 26 is, right? So let's get rid of the exclamation mark. Yeah, run one more time. Let's get some clean output, and then we can. We get the luxury of doing this because everything is so fast, right? We can just run it again and not have to simulate that in our head. Okay, now let's look at the end where we have. Equal length, and it's out of the loop. Yeah, good, great. It's just, no, it's missing the last character. Why is it
the last character? Because it assigns a random after we print. So if you notice, this is the one that's not.
Oh, I see. Yeah. Thank you, Turkey. Yes, that is correct. Yeah. In fact, we should have moved those two couts afterwards. But we can print another two afterwards, saying before and after. Two before and two after. For each iteration, we can print them. So all of those things are open to us. Now, anyway, we know what's going on. So it's now when it prints it out, that's good. Why is it breaking? So I think what's going on is that it's just breaking, right? Instead of repeatedly printing the same thing over and over, instead of being in that loop until it gets the final sentence, it's printing the junk once, and then instead of going to the top, it's coming out. So we need to find out why it's break, right? So let's put a breakpoint. Oh, step through it. Oh, we're not in a debugger. Okay, go to 40. Yeah, run it now. But tag the second part. Tag the second part with not there. No. Let's not use the. We'll just stick with the traditional debugging, plain old debugging. You
can just
right?
throw
before the three hyphens. Before the three hyphens, say after. Before the three hyphens, say after. After the /n. After the /n.
So line 46.
On line 46, after the /n. After the /n.
Like an A.
Yeah, say A or something like that, A colon or after or something like that. Yeah, after. And then you have to have the same thing in the other one too. Yeah. Great. I think that might give us more visibility into what's going on. Okay, after copy, you got that, which is great. Now the reason is now we want to find out why the hell is it exiting? why is it leaving the loop after having found the sentence? Right? So now you see how we've gotten so close. Now we're just one step away from finding what the problem is. So it kind of creates this adrenaline rush, like on the roller coaster, it's just about to get into the dip, right? So I think you'll start feeling that, and you have so many opportunities to fix these things, right? So it's just kind of cool. Why is it breaking out of the loop? Why copy equals
because the count size is the word, and it's exactly the same length when you pass it. So once it reaches that size, it exits that part because of the count.
Oh, but it should not exit the outer loop, but it should only exit the inner loop.
We only have one loop. We don't have.
Oh, we only have one loop. I'm so sorry.
Yeah.
I'm so sorry. Our logic was obviously wrong. Thank you, Turkey, for So this loop we have should be the nested inner loop. All right. So we need to have a loop on the outside, right? On the outside, just say for, and then get rid of the body, and this body should be the inner loop. Get rid of this body, and then except the copy equals s should be part of the outer loop. Right, just the copy. So the construction should be the inner loop, and after the construction, you do the comparison. That's part of the outer loop. Right. So we're further down. Now you have the copy equals s. Copy equals s equals break. Just copy those two lines and put them in the outer loop. Right after the brace. Yeah, copy that. Yeah, put it there. Enter. Put it there, and get rid of the cleanup. You got some blank lines where the old guys disappeared. Right. Kill. No, not there. Further down. There. You got some blank. Okay, now I think this, you change you can get rid of all of it. I'm so confident now that we can get rid of all the debug statements and change the /n to a /r. It'll actually work. Well, let's give it a shot, okay? Comment out all the debug. Oh, you're going to run it, okay. All right. Okay. It'll slowly fall into place, I hope. No, it didn't. All right. Oh, you're so confident, you're not even commenting it out. You're just deleting it. Okay, and change the /n into a /. All right, leave the /n maybe. Yeah. Okay, but you still have a /n. That's great. Oh, but it's still, there's a bug. It's only setting the t and it's not doing the rest. Or is it? It is doing the def. Yeah. Okay, it is doing the rest. Great. Okay, fantastic. All right, now let's turn the /n into a /r. Let's turn the /n into a /r. Okay, now, all right, now compile it, don't run it, and increase the size of the console so we have this good effect and all. So, and then we'll run it. Okay. Oh, it's really fast. Oh, at the end, you need to, at the very end, you need a /n. After you exit the for loop, after you exit the final for loop, just at the very end, no, after the break, after you break out of everything, yeah, there. No, not even there, because you broken out of the loop, right? Break out of even that loop, right? There, out there. You say C out, new endl. Yeah, that's fine. I think that should do it, but it still print junk there. Why didn't it print the final target? The copy equals s. Is s being declared local to the for loop because it's lost at the time? Go further up again. Further up. Copy is local. No, copy and s are both part of that. So copy has to be equal to s when it breaks out of the loop. Yes. Which means that when you print it, so print those two lines before the final thing. Yeah, cut it, get out of the thing, and put it. No, we don't want to print it every iteration. Just print it outside once, outside that loop. Yeah, enter. Yeah, run it now, and then you want to tag it saying it's not after anymore. It's going to be, final. Fin. You just say, oh, and there's no copy. Yeah. Final s equals. You can say final s equals. Is it final s? What did we print, by the way? I'm sorry. Let's look at what we printed. We printed the copy. Did we change the copy and print the copy? Yes. We changed the copy and printed the copy. Oh, but s is always going to be the same, so it doesn't. What we need is the value of copy. Can you make copy global? I mean, not global. Outside the inner loop. It is outside the inner loop, is it? Oh, it is. So you can print out copy. Both final s and final copy. Yeah. Okay. Great. Run it, and. Oh, but it had to be outside the loop. But it had to be outside the loop. Outside the. Oh, it is outside the loop, is it? Where is it? I can't see. Yeah, that needs to be outside the loop. Not even there. No. You have to close the loop there. There. Thank you. All right. Why is the final copy not equal to final s? Otherwise, why did it break out of the loop? So yeah, we were very close. I think we were last time we thought we were very close. We weren't very close, right.
I might mixed up which one is the inside for loop and which one is the outside for loop.
But we're breaking out of the outside for loop only when copy is equal to s. Yes.
The outside for loop only when I
not the
equal
outside
the
for
count
loop.
size.
Oh, the outside for loop should be while infinitely true. I'm so sorry. Thank you. Well, it should just be while true. I'm so sorry, Turkey. All right.
Oh.
That's what comes of trying to do too many things at the same time. Well, true.
So while
true, and you can get rid of all the debug. I'm pretty sure now. Famous last words. Okay, this time I'm pretty sure. Okay. All right. Willing to take the chance. Hang on. It's just a.
Inside this one we use it in I.
No. Wait a sec. Oh, that should be inside the loop. Oh, I see.
We just haven't declared I.
Oh, I think we changed the. All right, one sec. Okay, I think we messed up. Put it back. I think what happened was you changed the wrong for loop. Okay, so I will increase the size of the screen. I'm just looking at 3 lines at a time, so it's really hard for me.
Yeah, I'll fix this.
Oh, great. Okay, thank you. All right, so let's see. Can you? All right, great. Okay, as soon as you get the string, you create a copy. Where are you creating a copy? All right, so that for loop ends there. That for loop ends right there. I think we got it all mixed up. All right, so that for loop ends after. Now at that point, you can get rid of. In fact, you know what? Wait a second. No. Don't do any of that. Let me read. Some things have changed, so I just need to run the logic in my head first. What time is it? We got time. All right. So unfortunately, I think we'll only manage to do this today, but I'm happy to do the rest later for anyone who's interested. All right. But we'll actually get this function working today. All right. This is the very first for loop, very first for loop. Go a few more lines up. Sorry. All right.
Yeah.
So you got a copy, very first for loop. What you're going to do is for the length of the sentence. Okay. So what we want to do is put this entire thing inside of a while true. Put this entire thing inside of a while true. That is the first loop, okay? Not what you tagged as a first loop is not the first loop. This is the first loop, right? So this is the very first loop. As you say, it's the outer loop. Say it's the outer loop, outer first loop or whatever, right? Okay, good. Now the inner thing, you can just indent it, indent it. Not that the inner for loop should be indented inside the while. Indent the inner for loop inside the while. Yeah, it is already indented, is it? All right, let's go back to the top. All right, now while true, and then we're constructing the sentence. After we've constructed the sentence, you get out of the for loop, right? So the cout copy equals and cout dot flush needs to go out of that for loop, right? Get rid of the cout, the two couts, and move them out. Yeah, the two couts on top of that also. Even the two couts. No, there on line 45 and 46. Get rid of 45 and 46.
Oh,
that's okay. Yeah. Get rid of that, right? And take it out of the for loop, and but it's part of the while loop, right? After the closing brace of the for loop, hit enter. Hit enter. No, you went out of the for while loop. I think that's the. Yeah, I think what happened was that previously, one of those that miscommunications flared up. Okay, so go to line 40. I think I should use line numbers. Okay, line 45. Go to the end of line 45. End of line 45. Hit enter. Okay, now we're out of the for loop, but inside the while loop. Is everybody okay with this? Okay. Now this is a place where we should compare the copy that has just been constructed by the for loop with the target string s. Everybody okay or not? Okay. So let's
Well,
put
we're still inside the
there.
for loop from 29 at that point, aren't we?
I'm sorry.
If we're on line 46, like if you click on 46, I think it's inside the for loop. It starts on 24, isn't it?
Oh yeah. You don't have. I'm sorry. You don't have that closing brace on 46 and 47. Those two lines should go, right? Get rid of 47 also, because hang on one sec. I'm missing. What's going on here? Why do we have these loops? While true. Oh no, I'm so sorry. That's what happened. You don't even have that outer, you have two for loops. The outer for loop got replaced by the while. I think that was a miscommunication. Get rid of the outer for loop. We don't need that. The outer loop is basically an infinite while loop. That's all. Okay, good. I think that was a fundamental confusion. Right. I think that thing misled a lot of us, right? Okay, good. Outer loop, and then inside of that, you're going to take those, counts of I, move them into the for loop. Move them into the for loop. In fact, you don't even, I think you don't need that. You don't need that. Get rid of that. You don't even need that anymore. We put that all there to in our effort to debug these things, right? So good. I think it's all nice and tidy now. You can get rid of the those two also. Yeah, you can leave them there in comments. And then after after copy has been constructed, you can get rid of the two couts because you don't need to. You need to print the copy with a /r, flush it, and then those two couts can go. You can comment them out. All right. I believe that should work. Okay. Let's try it. Yeah, let's try it. That's it. It just ran. It's really fast. I think that's the reason we didn't see it. No, we'll make it bigger again. Yeah, bigger. Run it. Well, I think it was really fast and we didn't see it. Turn the /r into a /n. You'll actually see all those lines. It's so fast. Maybe it just got optimized out or something. Now you'll see all of the lines. It didn't? Oh, yeah. But okay. S equals copy equals s, right? We just need to clobber s. Change the first letter of s, right? Change s of 0 equals space. Just say s of 0. Just so after copy equals s, right? After line 29, after line 19, after line 19. It never even entered the loop. That's why. Now you say copy of 0 equals 0, right? a copy of 0, square bracket 0, equals 0, equals 0. And then within comments, you can do say whatever you want. Well, what if 0 happens to be a string? Just say letter 0, the value 0. That way it is not part of the string that was given to you. Right? Semicolon, semicolon. And then you can say in a comment, you can say, make sure a copy is different from S. So the loop will not be prematurely broken. Although I don't know why it broke out of the loop, because as soon as I entered the for loop, it should have changed copy anyway, right? So it shouldn't have been equal to S. Why did it exit? But so maybe we'll debug and find out, right? Why did it not even enter the loop? But yeah, now we have to uncomment this too. Yeah, let's uncomment that. It's building up. Yeah.
Yeah, we deleted the logic that generated random letters.
Oh, we deleted that? I didn't know we deleted that. No, we put,
because right now we have we're not running into the else condition now.
Why are we not running into the else condition? Cancel y equals 0, copy by.
Because at no point does copy not equal S, right?
I have a question though. What if it was this? Because what are we equaling to 0 at this point? Are we doing the value here or the character?
Right. What happened was, you remember, we set counts of I to a random number in a loop.
Oh, yeah.
Do we still have that? Do we still have
Nope.
that in the loop?
That's what we deleted. If we control Z.
Oh, we deleted that. Where did it go? Where did it go?
Let me copy this just in case.
Oh, no, yeah. No. Now we fixed it. It should work. Everything should work now. All right. So thank you. Whoever brought that up. Okay.
This is what we missed out.
Changed so many things now. I don't know.
Yeah, 29 and 30. There's your issue. So if you copy those and then Control R, you can put it back. But
yeah, put it back in a
sure
separate
if you'll
loop.
be able to
Yeah,
control
copy.
R
Cut it out. Cut it out there. Cut it out there. Go above the while true loop. Above the while true loop. Yeah. Now you can fill counts with random vectors. Yeah, you need to do found. Yeah, for. I'm so sorry. I think Turkey had it there before, and then I said, "Oh, remove that for loop," and so on and so forth, and we totally screwed up this program. All right, I is less than counts dot, not counts. Is it counts dot length? Yeah, counts dot size. Yeah, plus. And then you don't have to, meddle with copy anymore. Get rid of the copy of I equals space, because you already changed it. You set it to 0, right? The first character set it to 0. Is it still there? Copy of 0 equals 0.
No.
Copy of 0 should be equal to 0. Now you know for sure that S is not equal to copy. We don't want the two to be the same. All right. Now, no, go. I want to make sure while. All right. So that's good. Okay, good. I think this should be fine. I think this should work. You can get rid of. Yeah, you can get. Yeah. All right. You can get rid of the cout final one, and it should work. All right. Let's live on the edge. All right, run it and see if it works. Yay! Okay, now you can. Oh, you have a /n, not a /r. Okay, with /n it'll be /r. It'll be faster. All right. Because it's /n, it has to do the scrolling. Scrolling is very, very slow. Right? The /r, it'll be really fast, and it'll be a good effect.
Oh, it's good.
Yeah. It'll eventually.
Yes.
Yeah. This is a random sentence generated by human. Yay! What time is it? Okay. Hey, we got time. It's only 6:30, 9:35. Okay, is it 9:35? Yeah, we still got 15 minutes left. Okay, cool. Now that we've got the effect, and this is a class, right? Now let's split it up. Okay. Get rid of your main. Or comment the main out. Above the main, put a comment. Saying, this is a sample. This is a sample to show how the methods in DisplayWithEffect can be invoked. Okay. So which means that this file does not have a main. Okay, this is just a class. Okay. Okay, great. Okay, now go to the but the body of the function where you have the static declaration. Copy that entire cut it from the file. Cut the implementation. No, the entire function. That entire function. Cut it. Yeah. We only have the class declaration here. That's it. And even the comment above it, even the comment, including the, yeah. Okay, cut. Yeah, okay, great. Yeah, clean up, get rid of the blank lines, clean up. Great. Okay, now create a brand new file called, and rename this to be DisplayWithEffect.h instead of .cpp, right? So this is how you split up things into multiple files, organize things in a project. Now rename this into a .h file, not a .cpp file. All right, great. Now create a new file called DisplayWithEffect.cpp. Right here, you can get rid of everything except get rid of everything. Get rid of everything, right? Everything, including comments, right? Now hash include DisplayWithEffect.h within quotes. No, now because it's your own file and it lives in the current directory, you don't use angle brackets anymore. Angle brackets means go and search to find the file, right? Like vector, you don't have it, right? So you need to use no, but you have to use single quotes, double quotes instead of angle brackets. That means it's in the current directory. Okay, all right, great. Yeah, sometimes autocomplete gets in the way. There should be a way, some pack for VS Code that takes care of these things. It's the trouble, right? Finding the right thing is really hard.
No.
Okay. All right, now you can just paste your code, and paste it. Not that. Where's the function that you cut from the other file? Yeah, that function. Oh, did you put it there? Oh, is it there already? That's it. Yeah, great. This is it. So this is your header file. This is the implementation file. The header file should be empty, right? It should only have that those 4 lines. Go to the header file again. Where's your header file? No, header file doesn't have the function at all. You can kill the function. Header file only has a class def. I thought we cleaned it up. I remember vaguely that you cleaned up the header file. You didn't.
I think we mixed it up. So I deleted the header file from here and I added that one there. So in a second, I'll just fix this.
All right. So click, put it back. The header file should have the class def.
So
Yeah,
this will be in the header. Okay.
That is your header file. Okay. Your CPP should have the. Now again, you went too fast. All right. Okay. Good. That should be in your CPP file.
Okay. Here you go.
All right. Good. Let's take a quick look. Where's the top of your CPP file? Is there a hash include?
No, there's no hash include. I'll include it.
I don't know. Hey, you're going too fast for me. Okay, so you got to drive. Okay, I'm going to trust you.
Sorry. Here you go.
All right, and your header file looks good. Header. Where's your header file?
This is the header file.
Let's also make sure that we code defensively. Go to the top of the header file and say hash pragma once. Okay, hash pragma once. Now this, by the way, is the same as the hash include guards. That's Xcode and other things include for you automatically. Hash if not def, some if and def and so on, right? There's a nicer way to do that in later versions of C++. So we'll use that. Hash pragma once means ONCE and hit enter. Yeah, enter. Right. What that means is that this header file, let's assume that it includes another header file, and that header file includes this header file again. Then it will be an infinite loop of inclusions, right? Recursive inclusions, and the compiler will basically die. So to protect against that, we used to use a hash include. If not def this file, then include that. Otherwise, skip this entire. That's what we used to do, right? And ugly, right? And so hash pragma is just a shorthand version of that. Saying hash pragma means if you've already seen me, don't include me again. That's what it means. Okay. So all right. So this is your header file, and then your CPP file. Now let's go to your main. Create a main file. Create a main.cpp. Main.cpp. Yeah, and now copy and paste that main that you had in comments, and hash include display, hash include that thing, hash include your header file. No, if you hash include VS Code will autocomplete for you. Yeah, I think, yeah, .h. All right, now, yeah. In fact, you know what? Go to that DisplayWithEffect.h, that file. H file, get rid of the namespace standard thing and IOStream also, right? All those things should not really be part of your header file. Yeah, that and also the namespace. And that should be in your main right? Yeah, and there's a blank line. Okay, now go to your main, put it there, and you need vector and IOStream. And then your typically display our local header file goes after the system header files. Vector, 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 and then take your header file and put it afterwards. And then usually I have a blank line to say that's system and that's me, right? And a blank line after vector would, yeah, cool. All right, now in your main, do that other thing where you had that other main. You have it in comments somewhere. Oh yeah, there you go. VS Code auto-completed for you. Yeah. Now what you can do is in your games, the games that we're going to build, every time we want to send a sentence to the user, we can, instead of using drum roll, right, which, you know, drum roll is hard, and also visual effects like fancy graphics, you can actually do very, very simple ASCII based special effects, you know, very simple special, and see if you can, over the weekend. Is this Thursday today? Wow, it's Thursday already. So maybe over the weekend you can create more of these special effects, right? Now we created one called roll characters into place. Create more, right? Maybe you say characters that kind of fly in from the edges, right? The character starts there at 80 columns and then rolls to its correct column position. That, you know, or characters could be oscillating. All these things, you can try all these things, right? Now you have the power of the /R, right? So you can print the same line over and over again. Okay, now, yeah, oh, it's not compiling. Initializing argument 1. Why? Hang on. Why is it? Why is it not argument 1? Char. What's the error? What is the error when you compile it? Oh, int. No. Wait. Oh, const char start to int. Why does it think that this is an integer in the header file? Go to your header file. Roll chars into place should take a string, right? I see. Okay. All right. Go back to that. Yeah. Okay. Good. It needs an actual string, not a pointer. Okay, so go back. No, but on the previous line, yeah, take that into say that on the previous line. Say no, that's fine. No, that's fine. Go back in your main. Yeah, say above the display with effect line. Yeah, that line. Yeah, enter string s equals, and then that this sentence was. And obviously, when you have that lucky sentence, you can say string s equals lucky.get sentence. Yeah. All right. Enter. Because now you're going to start the logic of main. Enter that. Okay. Now you can say, yeah. Now I think that should compile. Yeah. It still doesn't work. It doesn't work. Hang on. IOStream vector.
You need to include string.
Yeah, hash include string. I'm very surprised. Hash include string. You know, this used to happen with Visual Studio, right? Not in Xcode. Maybe VS Code just inherited, right? A lot of the Visual Studio. No, it still says no one can. String does not name. Oh, using namespace standard. We're not using namespace. Oh, we are. Oh, I see. Oh, this doesn't know what string is. I'm sorry. I'm so sorry. Yeah, this function, you have to say std : string in your header file. Oh, you do say std. Oh, but you still need to hash include IOStream here, I think, unfortunately, right?
I see.
I think it's or the other option. No, dude. The other option is to pre-declare to the compiler saying that string is a class by saying class string and semicolon, right? You can do that. That's fine. And some people say using IOStream : string, things like that, right? For now, we'll just say that should work, right?
I think it does.
Roll chars. Oh no, all three in the same file. Oh, how are you compiling it? Your project build file, right? Your compilation now should use main.cpp and where's your G++ line? Get your G++ line.
Yes.
Where's your line? G+. All right, say main.cpp. No. Say what is it called? Roll. Just say roll. -o roll. ROLL. -o space roll. No, -o space roll. That's going to be the name of our executable, right? Roll.exe, right? Space and main.cpp. And then the other file. No. You have two CPP files now, right? Right. Main.cpp and display the tab. Yeah, tab should get it. .h. No, one more tab. One more. One more. Oh, no. D-tab, yeah, okay. Dot H. Okay, good.
Should it have the dot slash in there?
I'm sorry?
Should it have the dot slash?
The dot slash just means current directory. Doesn't matter. All right, compile it. We'll see if there's an error. If there's a compile error. Oh, it doesn't matter. Use dash standard equals C++. What is it that Mark found last time? C++ 0x or something.
One C.
Go to the G++ line again. Go to the G++ line again. Up arrow, and then backspace before the dash O. Backspace until you get to the before the dash O. Okay. I think it's dash std equals. No space there. No space.
One Z.
C++ 0x. I think that's what he used. 0x. I think that's what he used. Enter. No, I think 0 uppercase x maybe. Or it's maybe just x. Who knows? One of those two, right? Oh, did you mean C++ 0x? So it actually is 0x. Okay. Dash 0x. Dash O rule. Okay, what is the error? What is the error now? Dash pragma one. Get rid of the dash pragma ones. We know for sure that it's not being nested, right? So get rid of it. Maybe the syntax. Maybe the syntax is. No. You need the IO stream. Just get rid of the pragma. And these are blank lines. Okay. All right. Cool. All right. Now compile it. No, it's still. Yeah. Okay. Yeah. You don't need that. All right. Good. What is the message? What's the message? Undefined reference to display. Does it say undefined? Oh, .cpp. I'm sorry, not .h. .cpp. I was saying .h. I'm so sorry. Okay. Error static void. What does it say?
I think my compiler is causing this, maybe because I've been doing different kind.
Yeah, it'll be good if you can fix this, because I can only see like 3 lines at a time, 4 lines, 4 or 5 lines at a time.
Is it possible I don't have the right includes on DisplayWithEffect.cpp?
Oh, yeah. DisplayWithEffect.cpp has to include the header file. I don't think we included the header file there.
Oh yeah, and we don't have the string with the std.
Thank you, Mark. Yeah. You have to include the DisplayWithEffect header file here. All right, good. Thank you, Mark. Great. I think that should fix it. Get rid of the blank line while you're here. All right.
What if it was this? Because in a string and the vector, we need the standard.
Yes. Oh, I see. Yes. I think you need that too. Put it there. All of these header files, is for now. You can put it there. You can clean it up later. Okay.
So we say using.
No, this is fine. I think because you're only using vector.
I do think we need.
Run the hash include IO string.
Using namespaces there. Yeah. Great.
And maybe we need to include vector here too, because we have vector.
Yeah. Go ahead and do that. Hey, I'm sorry, guys. I mean, I know that some of you have to go now. What time is it? 9:50. You feel free to take off if you want. You're just looking at 2 more minutes, I think. It's almost done. Famous last words. Okay, we've been saying that for the last half hour. All right. Okay, but this time I'm pretty sure we're almost done. Hey, Mark, you forgot your interview.
Yeah, I should probably go. Later.
Okay. You're having too much fun. Oh, we're having too much fun here. Okay. All right. Best of luck. Okay. Good. All right. We're good. Good to go. I think you should run, right? Compile it. Yay. Okay. Now clear the screen and run it. I think we should see some good effects. Yeah. /roll.exe. And we should, strictly speaking, we should have generated a, get lucky sentence, right? We should have gotten a lucky sentence, right? Then we'll have the lucky sentence fade into view like this. So now, henceforth, when we develop these ASCII kind of games, we can use this class, right? So save this class and keep it, and then add more effects to it. And then, no, if you do srand, you'll get different letters each time, right? And different kinds of, right? If you do srand in main, in your main, if you do an srand, you'll get, now you're getting exactly the same kind of rolling. right? So with that strand, it'll be different. Okay. Hey, that's really cool. That's really cool.
Finally, we got
actually
it
works.
right.
Yeah, 20 years, 20, no, strictly speaking, not 20 years, more like 5 or 6 years. But still, I've always wanted to try this out. So this is cool. Thank you. Thank you. All right, this is the end of class. And we actually managed
I'm going to try it out here.
There's another game that we wanted to do. Yeah, you can go ahead and do it. I have time, right? People should feel free to drop off, right? The next meeting is not until like a couple of hours from now. So yeah, next class, what we'll do is we'll do this other game, right? Not Lucky, right? Lucky's, let's move on from Lucky to this other super lucky game, right? Because I think this idea that we've been trying to pull off in other classes, just to give you a preview of the idea, which we didn't get to doing today. Let's create a I'm not a sports guy, unfortunately. What do you call these teams that people buy? People like Steve Ballmer buy these teams. There's a group of 7 people or 10 people. You buy it, right? It's a team. Let's just call them team. We'll come up with better names, right? Team. A team will have, I don't know, 6 players. Okay, team will have 6 players, and the 6 players will be different skills, right? And the team manager has to rank the 6 players according to their skill level, so that when he or she needs to deploy them in the game, he can pull them off according to the skill level. Yes, that's how they do it, right? So what we want to do is this team gets given 5-6 players, and they all have random skills, right? And the team manager will now face off 2 of them against each other, right? And figure out the pecking order: who's the best player, who's the weakest player. Yeah. Okay. So that's a game we're going to build over the next couple of classes, maybe, right? A couple of classes, optimistic, right? So I was saying like 10 minutes for this program, and it took up the entire class, right? So, but I'm pretty sure we'll get this done next class, okay? Because, mainly because we already did it last quarter in a couple of classes. And so we're going to.
Okay.
Oh, you actually did the lucky sentence?
I ran to an error, but I'm pretty sure it's just a structure of the program. I just need to put the run it somewhere. But I already included the library, and everything here is included already.
Oh yeah. Okay, yeah, that's fine.
So I'm just wondering, where should I put the cout?
Oh, that's it. Nothing. No. Now, when you compile the program, compile it along with the .cpp file. No, go to the G++ line where you compile Lucky.
Oh, so I do the G++ file.
Yeah, go to the G++. And now all you need to build in your VS Code settings for the project. It'll say these are the files needed to build. You have to add display.cpp file, right? Now just adding it by hand. Okay. All right. And yeah. Now, yeah. Is that it? Yeah. Lucky. Oh, but you don't have main. Yeah.
I called it with a different name.
Did you change it so that Lucky calls DisplayWithEffect?
I didn't change it yet inside, so I need to add it.
Change it so that instead of cout, you're going to say instead of cout, just the last cout. Oh yeah,
This one.
Just that one. Yeah, just change that to DisplayWithEffect and roll into place. Roll charge.
I think this one is the one that pulls your lucky sentence with the.
Yeah. No, that's so far so good. Just line 167. Change line 167. Right? Change that to DisplayWithEffect, double colon. Yeah, no, one more tab. No, you're not constructing. One more tab. I think no, DisplayWithEffect, backspace. Yeah, no, double colon. Put the double colon. No, not space. Tab here. Tab. It doesn't autocomplete. Or hit R and then tab. Hit R and then tab. R tab. Okay, good. Enter. Now pass S there. Oh, found sentence, right? Semicolon, right? And push it, push it in. Okay, now that's fine. It should compile. Just say, you see how easy it is? We created the effect, and now this is a library. But now you can build many effects into this, and then release it as a library. Then anyone can use that library and choose the effect they want. All right, run it. No, not roll. No, not roll.
I named it roll.
Oh, you named it roll.
Yeah.
Unfortunately, there were no's. Oh, with your chosen word, you need to give it. Oh, bummer. You need to go
remember
/roll. No, say no. Up arrow, and then space. Do you have a package name? No, you don't have. Everything is fine. Just you want to run the command again, bro. Space. Do you have a package here? Harry Potter or something like that? Okay. Yeah, folder, space, and give it a lucky, give it blueberry, not blueberry, some word, right? Some word. And no, after the third parameter, after package folder space, space. I want to say the. It does say say some. All right, okay. All right, containing B is. Oh, all right. The dear millimeter rudely guessed on the boot storage. Okay, there you go. That's cool, isn't it? So we created the effect and then we tied it into something we did last class. Nice. Is everybody happy with this? Yeah. Nice, nice. And it's kind of cool, isn't it? We had some fun. Okay. All right. So, So I really boycott gracefully accurate tremor. Really nice. Really nice.
Because it's
You know, this is actually more interesting than just our class. You know, you should basically bookmark it and share it, especially on Reddit. This program, share the binary on, I don't know, somehow. Right? It's actually very, very fun. Very fun. Thank you very much for building it. Hey, I want to talk to some of you. Hey, by the way, hey, Isaiah, are you back? Isaiah, are you back? Okay, all right. So he's I think some of you have taken off. Oh, it's past 10 o'clock. All right. So, but I got to send some of you emails. But please do get in touch with me. Here's the important thing: stay in touch and finish. Okay, we will help you finish. Get to quest 6, you pass. Okay, no stress after that. And everybody's here. I can walk you through some quests if you've been putting in the effort and attending class, right? So we'll get you to quest 6 and you'll pass. Unless you want to take a fail. Some people want to take a fail because if you take a pass, then you can't do it again and better your grade, right? So some people say, I want to take a fail so that I can come back and get an A. Yeah, unfortunately, even at DianZa, right? If you get a C here and pass, you cannot do the same course at DianZa also, right? And maybe even UCs, right? I don't know, who knows? So, all right, good. Thank you all so much. And it is, yeah, 10 o'clock, right? Coming up to 10 o'clock, 2 minutes. Thank you all so much for, being very patient, and getting this done. I'm so happy, right? And yeah, thank you so much. And I'll see you guys on Tuesday, right? Feel free to reach out to me if you want a class before then or a Zoom or something like that. But certainly in summer, I'm available to teach you guys. Right? Bye. All right. See you later.
Thank you. See you.